to work out problems with the distribution law using algebra tiles. So let's get started looking at what is the distribution law or the distributive law in algebra. So if we have A times B plus C, so we have a number and we have a bracket including variables and numbers. This could also be a variable. Then what we need to do is we need to multiply each term in the bracket with that term outside the bracket. So that would give us, in this case, AB, which means A times B. Then we need to put that operation sign that we have within our bracket, which is a plus here. And we need to multiply A by our second term in the bracket, which gives A times C. And now we are going to use that law to work out a few examples. First one. So let's say we have 5 times x plus 3. So the first thing I'm going to do is I am going to use my algebra tiles to represent the term or the expression within that bracket here. So I have 1x, remember those green tiles were our x's, and I've got 3 units, 1, 2, 3. Now that 5 in front of our bracket tells us that we need 5 lots of this pack here. We need this pack, x plus 3, 5 times. So let's put that together. So we have here x and 1, 2, 3 units. Then I've got here another x and another 1, 2, 3 units. Then I've got another x here and another 1, 2, 3 units. And to get 5 packs, I need 1 more. So another x and another 1, 2, 3 units. Now I have got 5 lots of this bracket here. To simplify that, we need to collect the like terms. So what have we got here? Let's put our x's together and our units together. So let's push these together. So what have I got here? I have got 1, 2, 3, 4, 5x and these 5x represent 5 times x. 5 times x gives us 5x. And then I've got, oops, I wanted them to stay in pairs of, in groups of 3 to make it easier. So we have 5 lots of 3 units. 5 times 3 gives us 15. And we can count those 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this 15 represents 5 times 3, which is 15. And this is the solution to our question here, or our problem here. Let's look at another example. So let's say we have 3 times, remember there is no time sign between the bracket and the number, but it says 3 times 2a plus 1 equal to. We start again with that expression in our bracket. So what do we have here? We have 2a. Now we're going to use these tiles to represent a instead of x. Yeah, so this one of these is now a. So we have 2a and we have 1 unit. That's the term in the expression in that bracket. And now we need 3 packets of that. So we need another 2x and another unit. And we need another 2x and another unit. And to find the answer, we will again collect the like terms. So we have 3 times 2a gives us 1, 2, 3, 4, 5, 6a. Plus 3 times 1 gives us 1, 2, 3 units. And that's the answer to this problem. Another one. I'm now going to include the first negative. Let's say we want to calculate 4, or we want to simplify rather, 4 times 2 minus x. Remember, we are going to first start with the expression in the bracket. So we have here 1, 2 units, and then we have here an x. But in front of our x, we have here a negative sign. So we're not going to put the x here, but remember, if we turn it around, that is what represents our negative x. That means it's negative x. And now again, we want 4 lots of this expression here. So we have another 2x, another 2, and another negative x. And another 2, and another negative x. And another 2, and another negative x. So now I've got 1, 2, 3, 4 packs of this expression in the bracket here. And I'm going to simplify that by collecting my like terms. 1, 2, 3, 4. 1, 2, 3, 4 packs of 2 units. And what do I have here? Maybe you want to switch that around, but you already notice it doesn't matter whether I put the x's first or the units first. So we have here 4 packs of 2 giving us 4 times 2 is 8 units. And then what do we get here? 4 packs of negative 8 give us a negative, careful here, this is a negative 1, 2, 3, 4x. So 4 times negative x gives us a negative 4x. So, as I said before, usually we put the variables first. So we might consider swapping these round. And then we would have those negative 4x plus 8. But that really depends. Both of these answers are correct. This is just from a point of notation, a bit more consistent with how we use variables in maths. So that was our first example with negatives done. We're going to do another one. And now this negative is going to be in front of our bracket. So we have negative 2 times 2x plus 3. And there are several ways to go about this. For now, what we're going to do is we're going to start again as we did consistently here by placing or laying out our bracket. So I've got here 2x and 3. 1, 2, 3. And we're going to do this in 2 steps because we're going to first apply that negative here to our bracket, and then we're going to times it by 2. However, you can also do it the other way around. You can do the times 2 first and then the negative. However, I'm choosing to do the negative first simply because it's easy to forget it otherwise. So that negative here means when we apply it to that bracket, that we will have to turn all of our terms within that bracket over to the other side. We need to flip them. So what have we got then? We have here, instead of our 2x, we have now a negative 2x. And instead of our 3 here, we have a negative 3. And we don't have that negative in front of our 2 anymore because we applied that to our bracket. So that's the first step. And now it's the same as we did here. We need to get 2 packs of our bracket here, 2 lots of our packet. So we have another negative 2x. We have another 2 negative x. And we have another 3 negative units here. We have another 3 negative units. And now we're going to simplify our expression by collecting our like terms. And what do we get then? We get 1, 2, 3, 4 negative x, 2 times negative 2x gives us 1, 2, 3, 4 negative 4x. 2 times negative 3 gives us 1, 2, 3, 4, 5, 6 negative units here. And that's the solution to this problem here. One more. Maybe we would like to pause that video after I've written down the question to try and solve it yourself. That would be a good point to do now. So we have negative 3 times 1 take away a. So I've got two negatives now, equals. I would suggest that you pause the video now to try this on your own and come back once you have found a solution to see if you went correctly. Try to use algebra tiles to solve this though, yeah? So I'm assuming that you have paused the video and that you're tried to solve this problem and that you're back to see how to do it and if you did it correctly. Again, we're going to start out with our bracket. We have here 1 and we have negative a. I'm saying that this tile now, again, instead of our x, it is going to be our a. And this a is negative. And we said that in the first step, we are going to apply the negative to the whole bracket. And by doing so, we have to simply swap over, turn over our algebra tiles. That's what I did. So what do I get here when I apply my negative to the bracket? I get a negative unit and I get a positive a. And in front of our bracket, that negative is gone because I have applied it to my bracket already. So I only have that 3 here left. And now I'm going to make 3 packs or 3 lots of this bracket here. So I have another negative unit, another positive a, another negative unit, and another positive a. And I'm going to rearrange these to collect my like terms. And what do I get? I get 3 times negative 1 gives me 1, 2, 3 negative units. 3 times a gives me 1, 2, 3 lots of a's. And that's already the answer to this question. However, what I prefer doing is I am going to rearrange this so that I have the variables first, as we usually do in algebra. So I get here 3a take away 3. And that's the final answer to our solution, to our problem. However, I said already, this is perfectly correct as well. This is just a bit more consistent with our algebra notation. And this is it for today. Thank you for watching. I'll be back with a video on showing you how to use the distributive law if the term in front of your bracket is not a number but an x. And I'm going to make a separate video to show you how to work on this. Thanks for watching, and I'll be back.